Hey, what's up? It's Rahi again, still an 8th grader at Whitney High School. Anyway, previously we learned what electricity is, but the question is, how does it travel through wires and other things without going through them? Well, the answer is pretty simple. It's conductors and insulators. Alright, so what are conductors and insulators? Well, both of them are materials. Things like wood, plastic, metal, copper, or rocks. Anything you'd find around your house. But for a material to be a conductor, it has to be able to allow electricity to flow through it easily. Ever heard of a lightning rod? These things are useful because lightning is naturally attracted toward it, and it'll strike that instead of a building. Insulators, on the other hand, are also known as bad conductors, or have bad conductivity. They do not allow electricity to flow easily, and more or less stop it from moving at all, almost like a huge brick wall preventing you from entering something. Okay, these are some examples of conductors. Gold is an excellent conductor, but it's kind of hard to find and really expensive. Steel is, we kind of see that all around. It's in metal. Copper is what wires are made of, because electricity can flow through it like a tunnel really easily. And this surprised me really well, but seawater is useful in conducting too. I know, this one surprised me. And I'm not exactly sure how that works. Anyway, some good examples of insulators include glass, diamond, plastic, and wood. These materials do not allow electricity to flow through it. This is why houses are mostly made of wood, because they do not allow electricity to shock you, especially if you're inside, and especially during a lightning storm. A wire is an excellent example for an object that has both a conductor and an insulator, two opposites, working together. The inside of the wire is made of copper, which is a conductor. This is good because electricity can flow through it really easily and get to the place that it needs to go. Most wires have rubber covering it, which is another insulator. If the insulator wasn't around, the electricity would flow right out of the copper, right out of the wire, and to the outside. And this would be terrible, because you don't want wires to shock you when you're trying to plug something in. Alright, so did you learn something new? Because, personally, I was so surprised by the seawater being a conductor. Like, how does that even work? Hey, wait, I have an idea. What if you look around the room and point out two things that are a conductor and two things that are insulator? I'm sure you can find some. I can find some already. Well, this is Rahi, signing out. See you later!